Good afternoon, everyone, and thank you for joining us today in this joint training webinar being brought to you by Iron Edison Battery Company and Schneider Electric Solar. We're going to be talking about battery and systems design today. My name is Rhodes Carter. I'm the Technical Support Manager here at Iron Edison Battery. Also joined today with the founder and CEO of Iron Edison Battery, Mr. Brandon Williams. So our agenda for today, we're going to be discussing, first of all, just kind of a background of both the Iron Edison Battery, the company, and the products available from Iron Edison Battery. And then we're going to kind of do an overview of the various products available from Schneider Conext, both solar, grid-tied, off-grid components. Then we're going to take a quick break, and when we come back from our break, we're going to get into various system applications and design concepts that are compatible with both Schneider Electric and Iron Edison battery products, and then really get down to the nitty-gritty and talk about programming and configuring these systems to accomplish these specific design applications that we're going to talk about. If you have any questions during the presentation, please, we encourage you to email us those questions. Send any questions you can to info@ironedison.com. We're going to take a break going into the second half of our presentation to answer as many of the questions as we can, as well as at the end of our presentation. Any questions we cannot get to during the presentation, we will certainly respond to you via email. We're going to answer every question that's sent to us via email. So first, kind of talk about the Iron Edison Battery Company, and couldn't think of a better person to tell you about this than the founder and CEO of Iron Edison, Brandon Williams.
Thanks, Rhodes. My name is Brandon. I founded Iron Edison Battery Company in 2010 with a focus on teaching people about off-grid batteries. We started Iron Edison to show people the benefits of using alternative battery chemistries like nickel iron batteries that last longer and are more durable than their lead acid counterparts. We feel like teaching people about off-grid system design is the best way to help people to understand their needs and recommend the equipment that is just right for each application. So we're excited to share with you what we've learned today. And we always welcome any questions that you have. We have a team of dedicated system designers that is helping people across the country and across the world to design these really unique projects and educate people on the benefits of using these alternative batteries. Let's take a look at some of the different types of projects we typically work on here at Iron Edison. We focus on off-grid, residential, as well as grid tie, whether it's selling back to the grid or local self-consumption. We have recently we've recently started working on utility scale and commercial off-grid battery systems. We have been working for a long time with farm and agriculture systems. I have a special place in my heart for survival, preparedness, and bunker type projects. We also have batteries that are charged by wind turbines, and we even have battery systems that are in fully contained mobile systems. Let's take a look at some pictures of battery systems using the nickel iron battery and the Schneider Electric equipment. Here you can see a 24-volt, 600 amp hour nickel iron battery. All the batteries that you'll see in this presentation are contained within a vented battery box. They photograph a lot better before we put the final touches on the box, but please know that it is important to vent the nickel iron batteries using the vent fans that we include in our complete systems. In this particular system, we have two Schneider XW 4000 watt inverters. We also have two 60 amp Schneider Electric charge controllers. This is a little bit larger system. We're looking at an off-grid homestead with an 800 amp hour, 48 volt nickel iron battery. You can see we're keeping the batteries nice and neat on a two-step, two-tier battery rack. This 48 volt, 800 amp hour battery can deliver 38.4 kilowatt hours of total capacity. You can see here that the battery is photographed before the box is installed. I really like this solar array with the tilt adjustable array and a very clean installation of 2 XW6848 inverters with 4 60 amp charge controllers. Here's another off-grid project featuring a 48-volt, 500 amp hour nickel iron battery with 24 kilowatt hours of total capacity using a single Schneider XW6848 inverter. This project features a 5.2 kilowatt roof-mounted PV array using some very attractive black-on-black solar modules. And in this application, we had a full room ventilation system for the nickel iron battery. Here's a very large lithium iron battery project. This is a grid tie residence with a roof-mounted PV array. This battery is a 52 volt, 2800 amp hour lithium iron phosphate battery with a 146 kilowatt hours of total battery capacity. This application was designed to support 3-phase AC power. There are therefore 3 Schneider XW Plus inverters and 2 high voltage MPPT 80 amp charge controllers. This system was designed for backup of critical loads while selling excess energy back to the grid. Very special application here. All of the electrical equipment was placed in its own underground bunker. You can see the yellow gantry crane in the back of the bunker, as well as our Iron Edison BMS battery management system enclosure with some custom trays on the left-hand side that were specially designed to fit down a very small access hole to be carried over by the gantry crane. Here's some more photos of that same application. You can see a very nice house, the inside of the battery management system enclosure on the top right. On the bottom left, there's the photo of 3 Schneider Electric inverters and another view of our custom battery tray. Iron Edison is also working actively with some of our local partners on testing and development of how to use batteries and solar in new applications. We are proud to partner with Xcel Energy, our local utility, to learn more about how to use battery and off-grid solar in a residential simulator. So we are running a lithium iron phosphate battery here that was specially designed for this application with 1 Schneider XW Plus inverter, 1 high voltage charge controller, all contained within this shipping container. The upper left is a large display, and this battery is used to give tours and show people about how to teach people about the different components that go into making a complete off-grid system. You can see here we've labeled all the different components of our lithium battery, the battery management system, the current sensor, fuse, contactor, disconnects, and relays are all labeled somewhat like a science fair project so that people can come by and see the cutaway of the cells and see the different components and how they all work together. I had the opportunity to meet Federal Energy Regulatory Commissioner Sherry LaFleur on site, show her the benefits of using an off-grid battery system, and needless to say, her and her team were very impressed to see how these systems can operate on a local level. Here we have a little bit larger application. In fact, this is one of the largest batteries that we've ever built at Iron Edison. This is for a remote off-grid telecommunication site in Alberta, Canada. Due to the remote application or the remote nature of this project, we really couldn't, we had to rely solely on solar power to charge the battery. Because of the size of the battery and the size of the solar array, we've actually been able to reduce generator runtime by 285%. This is a huge battery, 260 kilowatt hours of total capacity. We have 2 Schneider XW Plus inverters. And the great part about using Schneider in this application is the fact that they're safe and designed to operate in the positively grounded environment that's required by a telecom application. Here you can see the solar array that's going in to support that 5,000 amp hour battery. Note the vertically mounted solar array so that the panels can catch the winter sun in this northern latitude. This is a beautiful picture taken from the boom right before we left the project. It's quite an amazing off-grid system here.
Now, I believe, Brandon, correct me if I'm wrong, this mission-critical communication site was running 24/7 on a fossil fuel generator. They made the choice to go green, really, and plus just eliminate the need to transport fuel out to this remote location. So by doing this and adding this battery-based solar system, they significantly cut down the generator runtime.
That's exactly right. One of the major challenges when running a generator-based cell phone tower or radio or telecommunications tower is that most of these towers will have two generators running one after another. If one of the generators shows an error or a low RPM, which is exactly what happened on this site, the customer has to put together a helicopter-based emergency repair and response team. That can cost tens of thousands of dollars to get that team out on site. So the benefit of using solar and battery is that there's no moving parts. There's essentially nothing to fail when this battery is operating on site. And even with a week or two of cloudy weather, there's enough battery energy to keep the system up and running, and they still have those generators on site as a backup in case all else fails.
Yeah, this site, it kind of seems disproportional, the size of the battery compared to the two Schneider inverters there. That's because they had 2 weeks of autonomy is what they required in the battery size here.
And a lot of the equipment is running DC direct using that positive 52 volts to run the radio telecommunications equipment.
Yeah, very neat application. Another application Iron Edison battery can provide is utility scale energy storage. With our nickel iron batteries, we can do containerized high voltage battery banks up to a 0.5 megawatt hour of capacity in a 40-foot container. In this particular configuration, the battery cost can be roughly 6 cents per kilowatt hour lifetime cost. So that's lower than most utility rates. So lots of different configuration options that are available. We're going to get into the two specific batteries that Iron Edison provides. We specialize in alternative chemistry battery solutions. The company was founded on the nickel iron battery, and for several years now, we've been also producing a lithium iron phosphate battery option. First, talking about the nickel iron battery. This is actually an old technology, something invented by Thomas Edison a little over 100 years ago, back in the early 20th century. A nickel iron battery is an alkaline battery, so there's no plate degradation like you would see in a lead acid battery. Nickel iron also supports an incredible depth of discharge. It's very tolerant in cold climates. It's a very long life battery. We say 30 plus years life expectancy. In reality, there's original Thomas Edison storage batteries from the World War II era that are still functioning today. So when you look at the depth of discharge and the long life, a nickel iron battery is going to have the best cost per cycle of any battery technology available on the market. Also the lowest total cost of ownership. The architecture of a nickel iron battery, it is actually a 1.2 volt nominal cell. Iron Edison offers nickel iron batteries from 100 amp hour up to a 1000 amp hour capacity in 100 amp hour increments. And what we do is we combine similar size cells in a series to create the battery bank voltage we need. So for a 12 volt nickel iron battery, you're actually going to have 10 individual cells in a single series. 24 volt battery bank will have 20 cells in series, and a 48 volt, like you see in the picture here, is 40 individual batteries in a single series to create a 48 volt nominal battery bank. And again, we can do larger voltages up to a 420 volt, actually probably even larger than that, by putting 350 cells in series. That was a containerized solution we saw just a moment ago. And the nice thing about nickel iron, because it's in 1.2 volt increments, we can do really any battery voltage that you need for custom, special, unique projects. The other battery offering from Iron Edison Battery is a lithium iron phosphate battery. Now, lithium iron phosphate is actually one of 6 different lithium chemistries that fall under the lithium ion umbrella. Lithium ion batteries have gotten some bad press lately, mainly for their thermal runaway or thermal events, that we affectionately call them. Lithium iron phosphate is by far the safest of the lithium ion battery chemistries. The batteries that you see in the news are typically a lithium cobalt chemistry. It has the highest energy density of all the lithium batteries, which makes it the least stable. In the event of a catastrophic failure with a lithium cobalt, you're going to have a self-sustaining fire where it literally is producing its own oxygen, so it's very difficult to extinguish. Really, the only way you can extinguish a lithium cobalt fire is with a special Class D fire extinguisher. They're kind of rare and very expensive. Most times you just have no choice but to sit back and watch it burn. And that safety reason is specifically why Iron Edison chose the lithium iron phosphate chemistry for our lithium batteries. Catastrophic failure with lithium iron phosphate, you're going to have venting steam, and that's pretty much it. Again, very high energy density compared to other battery chemistries, providing for a small physical footprint. Lithium is a maintenance-free battery. It's pretty much an install and forget battery. There's no maintenance you have to worry about at all like you do with other batteries out there. We use large format cells in our lithium batteries, which gives us the ability to have very high capacity and high voltage battery options. All of our lithium iron batteries include a digital battery management system, which is pretty much necessary with any lithium battery. Our BMS does cell level monitoring and active balancing of each cell in the battery pack. We're looking at the voltage, the current, the temperature, as well as the resistance of each individual cell. And we have the ability to actively balance and correct any minor deviations with each individual cell. Should a cell get out of tolerance to the level that we cannot actively correct it, there's fault protection and a shutdown mechanism built into the battery, so the battery will shut down if it can't compensate for anything that's out of parameters. The architecture of a lithium-ion battery bank from Iron Edison, it's a pre-assembled cell pack and the battery management system, completely enclosed in a blue enclosure like you see here. They are available in 12 volt, 24 volts, and 48 volt solutions. Amp hour capacities range from 180 amp hours up to over 5,600 amp hour configurations. And again, we can do high capacity and high voltage custom configurations. So if you have any unique challenges or special projects, these are the type of projects we really thrive on. So give us a ring or reach out to us however you can. Tell us the details and the requirements of the project, and there's a very good chance we can come up with a perfect solution for you.
Right now in our shop, just feet away from where we're sitting, our team is working on assembling a 3,200 amp hour lithium iron phosphate battery that will be connected to 9 Schneider XW6848 inverters. In that application, we have an external battery management system enclosure, and that battery is designed for high instantaneous draw applications up to 2,000 amps DC. That's a tremendous amount of energy, of current to be able to deliver at one moment. And the lithium iron phosphate batteries are the battery of choice when it comes to delivering a lot of current from a relatively small footprint. In fact, the lithium iron phosphate batteries take up a third of the physical space that a similar lead acid battery would occupy. So we're proud to design and assemble these batteries right here in our shop in Colorado. So again, if you do have a custom application that you're looking for some help, we are more than happy to give you some advice and design a custom solution for your project. Let's take a look before we jump into the Schneider equipment at something that's really important to know about comparing different types of lithium batteries. In a traditional view of depth of discharge versus cycle life, we've been trained over the years to look at a battery as full at 0% depth of discharge and empty at 100% depth of discharge. In this example, we're looking at a 10 kilowatt hour battery. And if we were to discharge this battery 100%, we would expect about 1,000 cycles of capacity until it reached what we call end of life. There's still some capacity remaining, but it's within the specifications where we say 1,000 cycles is going to be the maximum that this battery would provide, going from 0 to 100% depth of discharge. So what we're seeing today is software limited depth of discharge. This makes it very hard to compare apples to apples between different types of lithium batteries from different manufacturers, because although the chemistry is the same, what each company is doing is using software to limit the total battery capacity. In this example, what we're seeing some of our competitors do is deliver a battery, a 10 kilowatt hour battery, but software limit its available capacity to 8 kilowatt hours, meaning that full is at 10% depth of discharge and empty is 90% depth of discharge, essentially giving you 80% of the full true battery capacity. Our competitors are then publishing specs that say expected life at 100% depth of discharge is 2,500 cycles, when in reality, what we're seeing is these 2,500 cycles would correlate to an 80% depth of discharge number. We feel like it's really important to give our customers, our partners, the most honest information possible about our battery systems. We are always reporting the true capacity, the full capacity. If you want software to limit the available capacity and extend the cycle life, we're happy to work with you to design a system and a battery management system protocol to deliver more cycles. But we really think it's important to be honest and upfront. And we don't feel like using software limitations to skew the 100% depth of discharge versus cycle life is a good way to represent our products. So we're happy to help compare and contrast different spec sheets from different manufacturers to help you understand the difference between true depth of discharge and software limited depth of discharge.
Yeah, a lot of our specifications will actually, say, okay, this battery is going to have, say, 1,000 amp hour total capacity, and then at a certain depth of discharge, you can expect this amp hour capacity or this amount of kilowatt hours. So we probably give too much information. It can be a little overwhelming and confusing, but we want you to know exactly what you can expect out of a battery from Iron Edison. So now we've kind of given you an overview of nickel iron and lithium iron batteries. Let's just do a side-by-side comparison so you can see the pros and the cons of nickel iron, lithium iron, especially compared to lead acid batteries. First of all, the depth of discharge and life cycle expectancy. Nickel iron really shines in this category. We can do 80% depth of discharge on nickel iron battery, and we're not going to negatively impact the life expectancy. That's just one of the positive characteristics of the nickel iron chemistry. So doing a daily 80% depth of discharge, you can see 11,000 cycles out of the life of a nickel iron battery. Doing that daily, that's 30 plus years of life. Lithium iron batteries, like a lot of other battery chemistries out there, the deeper you discharge it, the shorter the life expectancy you're going to see. We've crunched the numbers and found if you're in a daily discharge situation, an off-grid solar home or something like that, where you're going to be cycling it every single day, 50% depth of discharge is kind of the financial sweet spot. You're going to get a 5,000 cycle life expectancy, cycling it daily, 14 years of life out of a lithium iron battery. If you're using a lithium battery as a battery backup application where it's not going to be cycled on a daily basis, but maybe weekly, monthly, a couple times a year, we recommend doing an 80% depth of discharge on the design when you size the battery. By doing that, you will get a shorter life, 2,000 cycles, but because you're not going to be cycling it on a daily basis, you're still going to get many years of life out of that lithium iron battery in a battery backup situation. Now, of course, compare these numbers to the typical lead acid battery. You can only do 30 to 50% depth of discharge with a lead acid battery, depending on manufacturer, and you'll get 1,000 to 2,500 cycles. Expected life, 3 years, 5 years typically. Best case scenario, maybe 7 years of life out of a lead acid battery. Looking at the battery type, nickel iron battery is a wet flooded cell, so it does require some venting and a little bit of maintenance, not nearly the maintenance required for flooded lead acid batteries. The only maintenance you need to worry about with a nickel iron battery, we like to have you check the electrolyte levels at least once a month. And that's very easy to do with a nickel iron battery. We have a translucent jar, so instead of having to pop the cap and peer down the vent with a flashlight, you can just look at the side of the battery and see where the fluid level is in relation to the minimum and maximum fill lines. So you can check a 48-volt nickel iron battery, which consists of 40 individual batteries. You can check the levels on that in about 10 seconds. Depending on how aggressively you're charging and using the battery, you'll have to top off the electrolyte with only distilled water every 1 to 4 months. And that's it for maintenance. Nickel iron batteries, you do not need to do equalization charges that you do with lead acid batteries. Also with nickel iron, you do not need to check the specific gravity. All you do is top them off with distilled water. And above and beyond that, we recommend replacing the electrolyte in a nickel iron battery about once every 10 years or so. That's going to help prolong the life of it. And over time, you're going to have a very slight loss in electrical capacity. And that's due to a carbonate buildup in the electrolyte. And by replacing the electrolytes every 10 years or so, you'll recover that capacity loss. And by doing that every 10 years or so, really the battery should last indefinitely. Moving on to the lithium iron battery chemistry, it is a sealed battery, completely maintenance-free, no venting required at all. So again, an install and forget it. And then lead acid batteries, they vary depending on what variant you have, wet or sealed. Venting varies as well, and maintenance, if it's a flooded lead acid, you're doing maintenance at least monthly, if not every couple weeks. As far as size and weight, nickel iron batteries are similar to lead acid, but their operating temperature is probably the greatest of any battery chemistry out there. Nickel iron batteries, they can operate from 22 below Fahrenheit up to 194 degrees Fahrenheit with no real noticeable performance changes. Lithium iron batteries, they really shine when it comes to size and weight. Again, roughly 1/3 of the size and weight of a flooded battery. So if you have an application where size or weight are critical, lithium is certainly something to consider. And finally, and most importantly, the economics of it. Price per usable watt hour. This number is the purchase price. Nickel iron batteries are roughly $1 per usable watt hour of capacity. Now remember the word usable, that's factoring in the supported depth of discharge. Compared to lead acid, well, yes, lead acid is a cheap battery, and that's probably the only benefit to lead acid batteries. But when you look at the lifetime cost per kilowatt hour, that number is the purchase price divided by the total kilowatt hours of capacity that battery can expect to deliver over its lifetime. Nickel iron batteries are less than 10 cents a kilowatt hour. Again, that's lower than most utility rates. Looking at lead acid batteries, up to 8 times as much. So yes, lead is cheap up front, but you have to spend that money again and again and again. And that makes them probably the highest total cost of ownership of any battery chemistry out there. So to summarize, nickel iron batteries, they have a great long life applications use. The best value or the lowest total cost of ownership of any battery chemistry you're going to find out there. Nickel iron is great for hands-on system owners because there is a little bit of maintenance required. Again, not nearly the maintenance regimen that you need for lead acid batteries, but you do have to maintain them just a little bit. Examples of nickel iron applications, solar renewable energy projects, especially in harsh or very cold climates. We've got a number of customers in northern Canada and Alaska using nickel iron batteries, and they're rock solid and working wonderfully well for them. If you have high voltage or high capacity applications, nickel iron is certainly something to consider, as well as just replacing or upgrading existing battery banks. Lithium iron phosphate batteries, they're great for applications where maintenance-free operation is critical, or if you need a very small footprint, or an application with a very high discharge rate, like the 3200 amp hour battery that we're working on right now, Brandon mentioned previously. Solar and renewable energy projects are great for lithium batteries, as well as battery backup applications. Mobile applications as well, including RV and marine. In fact, we have a project we're working on right now, a brand new custom yacht being built down in Florida that's going to be using a very large lithium iron battery of ours. And again, just replacing existing batteries. So that's a pretty good overview of Iron Edison battery and the alternative battery chemistries we have. So, there's a lot of inverter and solar component manufacturers out there, Brandon. Why consider Schneider Conext Power Systems over others?
Thanks, Rhodes. So the Schneider Electric product offering gives us a lot of options and a lot of flexibility when it comes to designing battery-based solar systems. There's a wide range of inverters. We can stack multiple inverters together. The systems integrate seamlessly over the ZAN bus network. Simply using an Ethernet cable to connect every device provides us with a single point of control and monitoring, whether it's locally based or remote online monitoring. The ZAN bus network allows us to link every device on the Schneider network together. In addition, the Schneider Electric inverters they deliver right out of the box 120 to 40 volt power, pure sine wave output. It's super clean power. And the inverters can also be configured for 3-phase 208 volt AC application. That's what we use here in the shop. A lot of other businesses use 3-phase, or even large residences may use 3-phase 208. So it's a very simple change to adjust or adapt these inverters to meet each specific application. So let's take a quick look at the overall design of a Schneider Electric system. What you see on the left-hand side of this diagram is 2 Schneider inverters. In the center is the Schneider XW Power Distribution Panel with 2 60 amp charge controllers. In this diagram, you see we've connected 2 solar arrays. Wind and hydro are also possible. We can connect an AC generator and the utility grid directly into the Schneider inverters. Some of the accessories that we commonly use are the system control panel and the auto generator start. The new line of inverters that you see here in the image are the SW inverter line. This is a little bit more affordable system with only one set of AC inputs. This is great for an off-grid or self-consumption model. Let's go ahead and look down the list of all the equipment that we will be covering today in the Schneider Electric portion of the webinar. We are going to discuss the SW inverter line and the XW Plus inverter line. We will be looking at the MPPT 60 and the MPPT 80 charge controllers. Then we'll focus on the SW Power Distribution Panel and the XW Plus Power Distribution Panels. This is, in my opinion, one of the most important parts of any off-grid or battery-based installation. These power distribution panels allow for a super neat and safe installation. It's really where we keep all of the wires for the DC and AC side of the project. In addition, we're going to look at the Schneider Conext system control panel, the ComBox for online monitoring, the battery monitor, which is a new accessory that uses a shunt for amp hour counting, as well as the Schneider Conext auto generator start.
The first inverter we're going to look at more in depth is the SW Solar Hybrid Inverter. This is a great inverter for off-grid solar applications or just doing a battery backup in a residential grid-tied application. The SW inverter is a grid zero inverter, meaning it does have an AC input, but it does not have the ability to sell energy back to the grid. It comes as a 120, 240 volts pure sine wave output. Again, a single AC input. So if you're grid interactive or connected to the grid, you can have the grid power come in to supplement your battery and solar. Or in an off-grid situation, you can use a backup generator. You can stack up to 2 of the SW inverters, giving you up to 8 kilowatts of power output in the inverter stack. And they have models both 24 and 48 volts, 2.5 kilowatt output, as well as 4 kilowatt.
The Schneider XW Plus hybrid inverter charger is the next product we are going to focus on. This is really the mainstay inverter of the Schneider Electric product line. This inverter is compatible with off-grid solar, grid-tied solar with battery backup, self-consumption, backup power like UPS or uninterruptible power supply, as well as peak load shading. The XW Plus inverter is capable of selling excess solar production back to the grid. And this inverter is configurable for 120, 240 or the 3-phase 208 application. It does require 3 of the XW Plus inverters for the 3-phase because each inverter takes over 1 of the 3 phases. We can then stack multiple inverters together to create a system up to 102 kilowatts. This system of this size does require a specialty built external combiner box for all of the inverters and the solar array to come together. We're happy to help provide that design and provide that as part of a complete system. There are 2 main models available, a 5500 watt or a 5.5 kilowatt 48 volt inverter, as well as a 6800 watt 6.8 kilowatt inverter charger. Both of these inverters are capable of delivering twice this amount of energy for 15 to 30 seconds. This would allow you for starting heavy loads like a motor or a pump or an air conditioner. It's also valuable in peak load shaving applications. In my opinion, the XW Plus inverter is one of the most feature-rich, it's one of the most versatile, and one of the easiest to install and set up. That's one of the main reasons why we love working with the Schneider equipment. Not only does it work, but it's able to work in such a wide range of applications, from one small system up to a very large commercial application.
As we get further into this, you're going to see for yourself that the XW Plus really is kind of the Swiss Army knife of inverter systems. I mean, I really can't think of anything it won't do.
It's quite an impressive unit. So right here built into the inverter, we want to show you an example of what the terminals look like where you actually land your cables. The Schneider XW Plus inverter eliminates the need for an external transfer switch when installing a generator along with the grid. What you can see here is the jumpers are installed for our 3-phase application where we're bridging leg 2 to neutral. We have wires landed on line 1 and the 3 different terminal slots. But what this just shows is that we have the AC load, which is the output side of the inverter, as well as grid and gen. So we have separate unique input ports for landing a backup generator and the grid. Now the grid is a bidirectional, so we can sell excess power back to the grid through that AC1 terminal strip, whereas the generator is isolated, will never sell energy back to the grid through that AC2 port.
It's also worth noting that, it says here AC1 is for the grid, AC2 is for the generator. That's not necessarily set in stone. If you have a strange situation where you have 2 separate grid sources, or in the event of like a remote telecom site that's mission critical, you may have 2 generators. You can have a primary and a backup generator, each one with its own input here.
That's exactly right. So the next product that we're going to look at here is the MPPT 60 PV charge controller. MPPT is maximum power point tracking. This is a breakthrough technology about 10 years ago that is a digitally controlled step-down transformer. So the original system design called for using 12-volt solar panels hooked almost directly to a 12-volt battery. The MPPT, or maximum power point tracking technology, allows us to attach a higher voltage DC solar array to a charge controller, and then through a very efficient 95 to 98% efficient transformer, we can step down that high voltage input to exactly match the battery voltage. This particular charge controller is capable of 3.5 kilowatts of maximum output in a 48-volt system. This equates to 60 amps DC of charge current going into the battery. The maximum DC input for this particular unit is right at the industry standard of 140 to 150 volts DC max. We'll see another unit here in a moment that has an even higher input if necessary. We are able to stack and synchronize dozens of charge controllers to meet, again, specific applications. We've used systems with 6 to 8 charge controllers out of our shop, and it's possible to use even more using some special configurations that we get from Schneider Electric. The MPPT 60 charge controller allows us to customize the charge voltages to match the exact requirements of the nickel iron or the lithium iron battery. So these are fully compatible with all the Iron Edison batteries. This particular charge controller is the one I use in my system, and it's a great economical solution for DC coupled solar arrays.
The next charge controller Schneider has to offer is the MPPT 80. This is a high voltage charge controller. It'll put up to 80 amps max charge current into the battery. But the unique thing about this charge controller is it'll accept between 195 and 550 volts DC from the solar array. It also has a integrated high voltage PV disconnect built into it, because you probably know you can't get high voltage circuit breakers very easily anyway to working with high voltage systems. Again, you can stack and synchronize these inverters or charge controllers for large solar arrays, and it also has the custom charge configurations that Brandon mentioned, making them perfectly compatible with Iron Edison batteries. The high voltage charge controller is ideal for a few different applications. One, if you have some very long wire runs between the solar array and your balance of system. I was actually curious, so I compared some kind of industry standard wire pricing versus the price difference between the MPPT 60 and the MPPT 80 charge controller, and found that if you have a wire run of about 200 feet or longer between your solar array and the balance of system, by going with a high voltage configuration, which means you have smaller wire between the 2 points and the additional expense of the MPPT 80, you actually break even at 200 feet. So really the ideal situation, if you have less than 200-foot wire run between the array and your charge controller, the MPPT 60 is probably be the more economical choice, but if it's greater than that, I'd seriously consider looking at the MPPT 80 as well. Also, if you have an existing grid-tied solar array that's currently using a grid-tied string inverter, and you want to upgrade or retrofit it to a DC-coupled battery-based system, this could be a direct replacement for a typical grid-tied string inverter. The voltages and current typical with an array like that will line up perfectly with the MPPT 80, so you don't have to get up on the roof and rewire the array or anything of that nature. Literally just take the string inverter off the wall, put the MPPT 80 in place, and you're good to go. Next, we're going to get into some of the accessories available in the Schneider Conext line. First is the system control panel. This is a very critical accessory. It is basically the central control point for the entire system. Using the ZAMBus network, the SCP will monitor and also allow you to configure every device on the ZAMBus network, all the inverters, as well as all the charge controllers and other accessories that we're going to get into here in a moment. Allows access to everything over on the network from one location, as well as you can have multiple system control panels on the same network. So for example, you could have a system control panel in your mechanical or utility room where all the balance of the system is installed, and you can put a second one in the living space in a residential installation, so you could easily access and monitor the system without having to go into the mechanical room. The system control panel has a few mounting options. It can be surface mounted on the wall with the bezel that's included with it, or it's also designed to be panel mounted in the XW Plus inverter or the SW Power Distribution Panel. And with the advanced configuration and programming options, really the system control panel is a mandatory component when configuring the system to work with batteries like the Iron Edison battery.
The next accessory we're going to look at is one of my favorites from Schneider Electric. It's the ComBox communication device. This is the new generation of monitoring and logging that allows us to access some amazing data, whether it's remotely or over the web. The ComBox, as shown on the top right here, allows us to log in and get a better visualization of the data. The bottom right shows the Android application, which is also the same main display you would see if logging in with your computer, that gives you a map of all the different components and allows you to track in real time solar production, grid usage or energy sold back to the grid, load consumption, as well as battery voltage and generator usage. The ComBox allows us to log up to 20 data points on a second-by-second basis and can send email alerts with production data, faults, monitoring, etc. It also unlocks some advanced configuration options that aren't available directly through the system control panel. It's important to note here that we can use the ComBox in an off-grid application where there is no internet available. What we have many customers doing, whether it's off-grid or just to keep their own secure intranet rather than the internet, they're able to hook up the ComBox to a Wi-Fi router that's not connected to any outside network or the internet. The customer can then log in through their tablet or their computer to get all the visualization, to see the data, to unlock those advanced configuration options without exposing the system to the outside network. The ComBox is required to unlock the next feature that we're going to look at, however, which is a cloud-based system. Schneider Electric is including a free lifetime subscription to the Conext Insight cloud-based monitoring service. The Conext Insight service draws the data from the ComBox and allows installers and customers to remain connected, allowing us to provide you with value-added services like making sure that your system is performing exactly as we design it. As you can see here, there's a great view of one-day solar production from one of our local customers here in Colorado, showing a typical bell-shaped curve of solar production through the day.
One question I get asked quite often about the ComBox is just accessibility. And really to kind of boil it down, there's two categories. The Conext Insight, the way it works is if the ComBox is connected to a network and it has access to the internet, what it's going to do is it's going to upload its performance and configuration data to Schneider's web server. And then from there, you can log into Conext Insight and look at that information. That's a one-way communication path, so it is secure. You don't have to worry about anyone hacking in via the internet, excuse me, and messing with your configuration or anything like that. It's just, as we say in the IT world, it phones home periodically to upload data, and that's it. There is no way for the Schneider system to take control, or I should say Schneider's servers to take control of your ComBox and make any configuration changes. Secondly, you can configure and modify the ComBox with a IP or a network connection on the internal local network only. So basically, the ComBox is going to get a local IP address from your own home network or business network, whatever it is, and then you can access the ComBox via a web browser or an Android app. And with using that and login credentials that you set up, both a read-only credential and an admin credential where you can make changes, then you can get in and modify and program the system. So you do need login credentials that you specify in order to make any changes to the configuration via the ComBox. I get that asked quite a bit. A lot of people have cybersecurity concerns and worry about hacking. So I just wanted to cover that to make sure everyone understood that.
But the last thing I'd like to note on the monitoring, whether it's the ComBox or the Insight, is that this is truly a plug-and-play monitoring solution. Having worked with a number of different brands and a number of different types of monitoring software, the ComBox and the Insight network is the easiest to use, the easiest to operate. It provides us incredible visibility into production and usage data. I think that this is one of the most breakthrough technological tools when it comes to monitoring and giving us visibility into energy production and tracking. I can't recommend this enough to include this accessory as part of any new system.
If you're an installer, using this Conext Insight can be a fantastic value-add tool for your customers. You can have a portfolio of all the systems you've installed, and from remote, keep an eye on them. And even be proactive with any potential issues. If you monitor this on a regular basis, it's very likely you're going to be able to identify an issue before the customer even knows about it. And you will be in great graces with your customer if you call them up and tell them, hey, I think your system might have an issue. I'm seeing some performance issues. Mind if I come out and take a look at it? And they won't even realize that there's a problem yet. So that's a huge asset as an installer. Moving on, the next accessory we're going to look at is the battery monitor. What the battery monitor does is it provides a percent state of charge measurement of the battery bank. The way it does this, there's a DC shunt that's included with this. And instead of just measuring the battery voltage to get a rough idea of the state of charge, the shunt is going to measure current flow both in and out of the battery, basically counting current or amps going in and out of the battery to give you an exact percentage state of charge. And by having this, the battery monitor will have the percent state of charge. It's going to report that state of charge through the ZAMBus network to all the other devices, inverters, charge controllers, etc. And by having that information, you can use that more detailed state of charge number to trigger various events like recharging the battery, triggering a generator start, switching to and from the grid for backup, things like that. So it's a very handy add-on accessory for more detailed control and management of the system.
The next accessory we're going to look at is the Schneider Automatic Generator Start. This is also known as AGS. The AGS is absolutely required for any system that's going to include an external fossil fuel powered generator. We have generators that we see that are powered by gasoline, diesel, propane, and other sources. So this auto generator starter AGS device is able to interface with almost every brand of remote start generator on the market today. Whether it's a 2-wire start stop, 3-wire, we have options for choke, for glow plug start, for diesel. Really, you name it. We have tons of different ways we can configure the AGS to start or stop the generator. The AGS, when installed, unlocks a new set of menus that allows us to start and stop the generator based on battery voltage, percent state of charge. We can start the generator to support heavy AC power loads. If the generator does not include its own exercise feature, we can use the Auto Gen Start AGS to control generator exercise. And it also allows us to manually start and stop a generator using the system control panel or the ComBox, meaning if you know you're going to start up a heavy load like a welder for the next couple hours, you can go over, push a button on your system control panel and start the generator without having to go out to a remote room or gen building to start or stop the generator.
And Brandon, it's worth a little side note here, excuse me, to talk about different types of generators. There's a big variety out there, and a lot of people don't really fully understand or realize this. Grid-tied generators are out there, as well as off-grid generators. The grid-tied generators, we'll start with that. These are the ones that you typically see at the big box home improvement stores. They're designed to automatically start up when the grid goes down, and then continue running until either one of two things happens. Either the grid comes back up, or we run out of fuel. These generators have a transfer switch included with them. So we've got our grid power coming into the transfer switch, as well as the generator power. And then the output of this transfer switch powers the entire house or whatever the loads may be. And in that transfer switch is a current sensing circuit. And what it's doing is just monitoring to make sure grid power is present. So if the grid power is ever interrupted, that is going to trigger the start on this generator. The generator is going to start up instantly, or maybe a slight delay depending on how it's programmed, and then switch the transfer switch over so that the generator is powering all of your loads, and then it's going to just keep monitoring for the grid to come back. And once the grid does come back and it's qualified, it'll flip the transfer switch back over to the grid and shut the generator off. Because of all this grid interactive circuitry and transfer switch that's included with a grid-tied generator, they're difficult to integrate with an AGS or an off-grid solar system. I won't say it's impossible, but it can be difficult to do. That's why we recommend using an off-grid generator instead, ones with electric start, obviously. These generators don't have that transfer switch or the grid current sensing features. They basically have a remote start-stop logic input, and they're looking for a command to start up and to shut down. And those commands will be sent to it by an AGS like the Schneider AGS or AGSs from other manufacturers. These, again, are the best solution for an off-grid or a solar system or any system that's using an AGS to control the generator. There's also manual pull start generators out there. Obviously, they don't have an electric start, so they cannot be controlled by an AGS, but they still work just fine with off-grid solar systems. You just need to go out and start the generator via Armstrong, as we say. You got to go out and pull the handle, fire it up, and depending on how the inverter is configured, as soon as it sees power from the generator, it'll start using it. So I kind of want to give you that overview of the different types of generators and the advantages or disadvantages to each one. Next, we're going to get into the power distribution panels that are available from Schneider. First one, this one is compatible with the SW inverter line. Provides a very neat, clean, and safe enclosure for all the system circuit breakers and wiring, both on the AC side and the DC side. With the SW PDP, you can incorporate one or two SW inverters, as well as a MPPT charge controller, either the 60 amp or the 80 amp, and a single battery bank. Included in it, the DC power distribution panel up on the top right. It comes with a 250 amp breaker for the battery to inverter connection, as well as two additional spaces, as you think you can see there, for the input and output breakers for your charge controller, PV input and charge controller output to the battery. The AC power distribution panel there at the bottom includes an AC input breaker for whatever that input source may be, grid or generator, as the output bypass assembly for the output of the system, as well as additional space for 8 single pole or 4 double pole AC breakers. So if you have a small cabin type application with very limited AC loads, there's enough room for AC breakers in this that you probably could bypass a separate service panel and just put all of your AC load breakers in this power distribution center. Here's a couple pictures of a fully integrated system. Obviously with 1 or 2 SW inverters. And also it's worth noting, you can see, if you look closely on the DC distribution panel, the Conext system control panel is mounted inside the power distribution panel, making for a very nice, elegant installation. And of course, if you have a dual inverter situation like you do on the right, you have space for another accessory, maybe a battery monitor. You could be mounted in there as well.
This next power panel is a new addition to the Schneider Electric family. It's the XW Plus Mini Power Panel, or PDP, which is Power Distribution Panel. This Mini PDP is set up for a single XW Plus inverter and provides a neat, clean, and safe enclosure for all the system circuit breakers, and wiring on both the AC and DC side. As I said before, the power distribution panel is such a critical part of a great looking and code compliant installation. If it's really a huge struggle to try to mount these 250 amp DC disconnects and the AC input output bypass assembly, the DC circuit breakers for the charge controllers elsewhere. That's not a good idea. We highly recommend using these power panels. They have numerous conduit knockouts. They're easy to integrate. They're designed from the ground up to work with the Schneider inverters. So we highly, highly recommend this. This is not a product to skip with an installation. This, as I said, this XW Plus mini power panel connects to a single XW Plus inverter. It connects right down below at the bottom of the inverter. It includes one 250 amp DC disconnect, as well as the places to land the battery positive and battery negative cables. There's also bus bars and labeling and all the wiring to land the AC input and output, and the wires to connect from the power panel to the inverter. The AC output and bypass assembly is included, and the AC input breaker is included. If you need additional circuit breakers for charge controllers, that's exactly what our team is here to do. Help recommend and size those circuit breakers to fit your specific application. So, Rhodes, can you tell us a little bit about why you would include an bypass assembly from the AC side?
Yeah, the bypass assembly can be quite confusing. I had some difficulty getting my head around it when I first got into this industry. Basically, it is a output selector. That's how I look at it. There's two breakers located there, one of them for the inverter output and one of them for the generator. And you can basically select what you want to have powering the loads downstream of the inverter. A normal operation, you're going to have the inverter powering everything directly. But if for whatever reason it may be that you need to take the inverter offline for maintenance, whatever you can think of, you can flip that bypass switch, and the AC input will then bypass the entire inverter system and power your loads directly. So if you have a generator or the grid, whatever is connected to your AC input, if you flip that bypass assembly, whatever's coming in that AC input is going to power your loads directly. The inverter then can be taken offline without taking all your loads down for service or whatever it may be you need to do. So, the mini power panel, again, great for one inverter and one charge controller. If you're going to be doing a multiple inverter, multiple charge controller application, then the XW Plus power distribution panel is the way to go. Again, nice, clean, neat installation solution to contain all the wiring and circuit breakers. The XW PDP will support up to 3 of the XW Plus inverters, as well as 4 charge controllers. There's some additional conduit box installation kits required for the additional inverters. It comes with a 250 amp DC breaker for the first inverter, plus there's room for 2 additional 250 amp breakers for inverter number 2 and inverter number 3. There's 8 DC breaker expansion positions for the charge controllers. You can have 4 PV input circuit breakers and 4 charge controller output circuit breakers. We've also done applications with up to 8 charge controllers using the XW Power Distribution Panel. What we typically do there is put all of the charge controller output breakers in the power distribution panel, and we'll relocate the PV input breakers to a separate box on the wall adjacent to the power distribution panel. This also includes the AC output and bypass assembly I just described, and it has all the input breakers for both the AC1 and AC2 inputs, and 5 additional AC breaker expansion positions. If you're doing all 3 inverters, those will get occupied by the additional output bypass assemblies as well. So to give you an idea of what a multiple inverter application or installation would look like, up at the top we have got a 3 inverter installation, and this one actually was retrofitted after the fact. A customer of ours started out with a single inverter doing 120/240 split phase. later realized that they needed to upgrade their infrastructure to three-phase. So we added 2 additional inverters, reprogrammed them. So instead of doing split phase, they're all now doing a 208 three-phase output. So as you can see, you can mount the inverters on either the left side or the right side of the power distribution panel. Bottom left, we have a 2-inverter installation, obviously, and then at the bottom right, a single inverter with a couple of the MPPT 60 charge controllers that mount right to the side of the power distribution panel.
Here's a great view inside the power distribution panel on the left-hand side, as well as an inverter with both the service panel and then the main circuit board protection panel removed. We typically don't need to remove that main panel. This is just to get a view inside of the inverter. On the right-hand side, you see the inverter with the service panel removed. Typically, this is the only part that we need to take off to install all the different AC wires. What we want to show here is that the conduit extension boxes that run underneath the middle and right inverters have so much room available to do all of the AC and DC wiring. Having worked with 2- and 3-inch conduit, whether it's PVC or metal, it's really tough to be able to squeeze all your wires through the conduit to make these tight bends. It's really cumbersome process. So these conduit extension boxes, as part of the power distribution panel, provide us so much room to work. It's important to note that on the left-hand side, when the work is complete, we have panel covers that will cover up all the wires, providing that a really safe and clean look at the end of the day. On the left-hand side of this power panel, on the top, labeled with the red tape, is the 3-phase AC input and output and bypass breakers. You can see there's a white plastic box at the top, and this is a special assembly made by Schneider Electric to take a single leg and split it up between the 3 different sets of breakers. On the bottom left-hand side of the power panel, you can see there's 2 sets of panel mount breakers for the charge controller inputs and outputs. And on the right-hand side of the power panel are the 3 250 amp DC disconnects for the 3 inverters that we used in this 3-phase application. So just a great view, give you an idea of how easy it is to work with this equipment when installing.
Yeah, having all that extra space in the conduit boxes is really handy. If anyone's done an installation before, you know that working with 4-aught cable, it can be quite challenging, and it's not the most flexible stuff in the world. So having that room in there to maneuver the cable and then get your tools in to land those connections, that really makes the installation a little more pleasant for the installer. So that's a good overview of all of the Schneider Conext products, as well as the products offered by Iron Edison Battery. We are going to take a quick intermission, let you get up, stretch your legs a little bit. And while you're doing that, we're going to go through all the various email questions we've gotten so far. Please, if you have any questions, we strongly encourage you to drop us an email at info@ironedison.com. And again, we're going to go through those questions, answer as many as we can when we come back from this break. And then if we don't get to your question right away or during the presentation here, don't worry, we will definitely respond back to you via email. We're going to answer every single question that was sent in to us. Coming up after the break, we're going to look at some specific design concepts of everything from a typical off-grid battery-based system to integrating batteries into grid-tied systems, as well as some commercial and utility applications, including just battery backup as well as peak load shaving. So again, email us any questions that you have. Info@ironedison.com, and when we come back from the break, we'll do our best to answer them. Anything else? Closing words, Brandon?
Thanks so much for being a part of the first section of our webinar on Iron Edison batteries and Schneider Electric equipment. As I said, our team is always happy to answer questions and to help you learn about these various components. No question is too small. Please send us an email or give us a call. We are always happy to help.
All right, take a quick break. We'll be back in about 10 minutes. Thanks for joining us.